If you still think Chinese AI models are years behind OpenAI, Anthropic, and Google, that take is out of date. As of May 2026, the serious question is no longer, can China catch up? The question is, where has China already caught up, and where does the West still have a real lead? Stanford's 2026 AI Index says the US-China AI model performance gap has effectively closed. It says American and Chinese models have traded the lead multiple times since early 2025, and by March 2026, the top Western model was ahead by only 2.7%. But that does not mean China has won. It also does not mean the West is finished. Because the AI race is not one leaderboard. It is a full stack: models, chips, data centers, apps, safety, censorship, trust, price, and distribution. So today, we are comparing Chinese models with Western models properly, how far behind Chinese models really are, what they do well, what they do badly, and why the next phase of AI may be decided by cost and deployment as much as raw intelligence. Here is the clean version. Chinese AI models are not years behind anymore. On open-weight models, China may be one of the strongest players in the world. On cost performance, China is extremely strong. On coding, long context, and agentic workflows, Chinese labs are now serious frontier competitors. But on the strongest closed frontier models, the most reliable enterprise deployments, cyber and safety evaluations, high-end chip access, and global trust, Western labs still have important advantages. So if someone asks, how far behind are Chinese models, the honest answer is this. In raw model capability, often only months behind, sometimes tied, and sometimes ahead. In the full AI stack, still behind the West in several critical areas. For years, the AI race was easy to describe. The United States had OpenAI, Google, Anthropic, Meta, Microsoft, and the cloud giants. China had huge talent, huge data, and strong government support, but its frontier models were usually seen as followers. Then DeepSeek changed the mood. DeepSeek v3 showed that a Chinese lab could build a huge mixture of experts model with 671 billion total parameters, only 37 billion active per token, and a reported training run of 2.788 million H800 GPU hours. The important point was not just the benchmark score. It was the message: clever architecture and engineering can narrow the gap, even under chip constraints. Then DeepSeek R1 pushed Chinese reasoning models into the global conversation. Alibaba's Qwen 3 followed with open models up to 235 billion total parameters and 22 billion active parameters. Moonshot's Kimi K2 focused on agentic intelligence and coding. Z.Ri's GLM 4.5 targeted agents, reasoning, and software tasks with a 355 billion parameter open model. MiniMax pushed fast, cheap agent workflows. This is no longer a one-company story. China's AI ecosystem now looks like a full competitive field. DeepSeek is the efficiency shock. Qwen is the open model platform play. Kimi is the agentic coding play. GLM is the research-heavy frontier play. MiniMax is the fast agent workflow play. That is why the old phrase Chinese models are just copies is too simple. There are real debates about distillation, benchmark optimization, and training data. But the engineering output is real, and Western labs are treating it seriously. The first strength is price performance. Chinese labs are building under pressure, less access to the most advanced chips, massive local demand, and intense competition between domestic AI companies. That pressure has created a pattern: build models that are strong enough, cheaper to run, and easier to deploy. The second strength is open weights. Western frontier AI is mostly closed. GPT 5.5, Claude Opus 4.7, and Gemini 3.5 are powerful, but developers cannot download their weights and run them in their own environment. Chinese labs have taken a different path. DeepSeek, Qwen, Kimi, GLM, and MiniMax have all pushed open or open-weight releases that developers can test, host, fine-tune, or build around. That matters. A bank, startup, university, government office, or local cloud provider may not want every sensitive prompt going to a foreign API. Open weights give them control. The third strength is MO efficiency. Many Chinese frontier models use sparse mixture of experts' designs. Instead of activating the whole model for every token, they route tokens through selected experts. That can reduce compute cost while preserving the capacity of a much larger system. The fourth strength is coding and agents. Kimi K2 reported strong results on coding, math, and reasoning without extended thinking. GLM 4.5 reported strong scores on agentic, reasoning, and software benchmarks. MiniMax M2 and M2.7 target coding, tool use, and multi-step workflows. DeepSeek version 3.1 added hybrid think and non-think modes and emphasized tool use and multi-step agent tasks. Qwen 3 focuses on reasoning, multilingual tasks, and tool use. In plain English, Chinese models are no longer just chatbots. They are being designed to act, code, call tools, read long documents, and complete workflows. Now the harder part. Chinese models are strong, but they are not equally strong everywhere. The biggest weakness is trust-sensitive performance, cyber, software engineering reliability, jailbreak robustness, and political neutrality. NIST's Center for AI Standards and Innovation, a U.S. government body, evaluated DeepSeek models and found that the best U.S. reference model outperformed DeepSeek version 3.1 across almost every benchmark it tested. The gap was largest in software engineering and cyber tasks, where the best US model solved 20 to 80% more tasks than the best DeepSeek model. CAISI later evaluated Kimi K2 thinking and called it the most capable PRC-based model it had evaluated at the time. But it still found Kimi below leading US models in cyber and software engineering, even while Kimi performed strongly in some math evaluations. That matters because coding demos can look amazing, but production software engineering is not just write code. It is debugging, security, testing, tool use, environment awareness, and knowing when not to act. The second weakness is censorship. CAISI found that DeepSeek models echoed more CCP-aligned narratives on politically sensitive questions than US reference models, especially when prompted in Chinese. Its Kimi evaluation also found Chinese language censorship patterns. That does not mean every Chinese model behaves identically. But for global buyers, it creates a serious trust question. If a model changes behavior around sensitive political topics, what else changes under pressure? The third weakness is safety process. Western labs have their own problems, but OpenAI, Anthropic, Google, and others now publish system cards, model cards, safety frameworks, preparedness evaluations, and enterprise controls. Some Chinese labs publish strong technical reports, but fast open-weight releases can move faster than safety documentation. The fourth weakness is hardware. The model gap is smaller than the hardware gap. Stanford's 2026 AI Index says the United States hosts far more AI data centers than any other country and attracts far more private AI investment. China has huge ambition and domestic hardware programs, but export controls on advanced chips still matter. Ironically, those constraints helped create China's efficiency culture. But constraints are still constraints. The West still has the strongest closed frontier ecosystem. OpenAI's GPT 5.5 is positioned as a frontier model for professional work, coding, tool use, long context, computer use, science, and cyber. GPT 5.5 Instant also became the default ChatGPT model in May 2026, which means OpenAI is not just building models. It is distributing them to a massive user base. Anthropic's Claude Opus 4.7 is positioned around coding, complex multi-step workflows, vision, and computer use tasks. Claude has become a serious enterprise and developer tool, especially in coding environments. Google's Gemini 3.1 Pro reported a 77.1% verified score on ARC-AGI2, and Gemini 3.5 Flash was introduced as Google's strongest agentic and coding model yet. The Western advantage is not just model intelligence. It is productization. ChatGPT has distribution. Claude has developer trust. Gemini has Google integration. Microsoft has enterprise channels. GitHub has coding workflows. AWS, Google Cloud, and Azure have enterprise infrastructure. For many companies, the question is not, which model won one benchmark? It is, Which model is available in my cloud, with legal terms, audit logs, data controls, uptime guarantees, support, and security approvals? That is where Western labs still have a major edge. But the West has a problem. Closed models are powerful, but they are expensive and controlled. If a Chinese open-weight model gets close enough, many developers will choose the cheaper and more flexible option. This is why Chinese models matter even when they do not beat GPT 5.5 or Claude Opus 4.7 outright. If Qwen, Kimi, GLM, DeepSeek, or MiniMax can deliver most of the capability for a fraction of the cost, and if a company can run that model locally or through a cheaper provider, the business case changes. The winner may not be the model that is smartest in a lab. The winner may be the model that becomes infrastructure, good enough, cheap enough, open enough, and easy enough to deploy. That is the pressure Chinese AI is putting on the Western frontier. So let us compare them layer by layer. Raw model benchmarks. China is close. Sometimes behind, sometimes tied, sometimes ahead depending on the task. Open-weight models. China is one of the strongest players in the world. Closed frontier models. Western labs still lead overall, especially OpenAI, Anthropic, and Google. Coding. Both sides are strong. Western models often look more reliable at the top end. Chinese models are often more attractive on price and openness. Agents. Both sides are racing hard. Western labs have better product ecosystems. Chinese labs are pushing fast open alternatives. Safety. Western labs have more visible safety process. Chinese models face serious trust questions around censorship, jailbreaks, and geopolitical risk. Infrastructure. The US still has the stronger data center, chip, cloud, and capital base. Adoption. Western models dominate global consumer and enterprise mindshare, but Chinese open-weight models are spreading fast through developer ecosystems. That is the real comparison. No simple winner. Different layers. For developers, the answer is simple: test models on your actual task. Do not pick a model because it is Chinese. Do not pick a model because it is Western. Do not pick a model because one leaderboard says it is number one. Test it on your documents, your codebase, your latency limits, your budget, your privacy requirements, and your failure cases. For businesses, the checklist is bigger. Ask, is the model accurate enough? Is it cheap enough? Can we control the data? Can we audit the outputs? Can we run it in our region? Can we trust the vendor? What happens if regulations change? What happens if the model refuses, hallucinates, leaks, censors, or gets jailbroken? In low-risk tasks, a cheaper Chinese open-weight model may be the best choice. In high-risk enterprise, legal, finance, healthcare, government, or cybersecurity tasks, Western frontier models may still be easier to approve, even if they cost more. The future will probably be multimodal. Companies will use one model for search, one for coding, one for internal documents, one for local deployment, and one for high-risk reasoning. So, are Chinese models behind Western models? Yes, in some places. But not in the way many people still imagine. They are not 2 years behind. They are not just cheap copies. They are not a side story anymore. Chinese AI labs have built a serious open-weight ecosystem that is pressuring the entire Western frontier. They are moving fast, optimizing hard, and turning chip constraints into an efficiency culture. But Western labs still lead in the strongest closed models, global distribution, cloud infrastructure, safety process, and enterprise trust. The smartest way to understand the race is this. China has nearly closed the model gap. The West still leads much of the AI stack. And the next phase will not be won by the lab with the flashiest demo. It will be won by whoever can make intelligence cheap, useful, safe, trusted, and everywhere. That is why this race is just getting started.